Okay, so things have moved on yet again. I've now got the same hardware arrangement, but it's running a bit differently in terms of the code. So I've still got the Pico probe and this Pico here, which is emulating a transputer, a non-floating point transputer, and that is attached over here using a transputer link running at the transputer 10 megabits per second at 3.3 volts here with some level shifters into the IMSC 11. So that's the transputer link to parallel interface. That then goes into an Arduino Mega embedded here. This is all the same as it used to be. It's a little bit warm, that. That then goes off through USB to my laptop, which is running a server program. Now the OLED display is still displaying what's coming from the transputer, so that will display things like Hello World coming out of a Hello World program. Now I had a Hello World program running before. That was on the transputer. That was hard coded in an array. The program itself, the bytes, the ROM if you like, were actually in the program. So I've got the same program running. It's had to be modified a bit because I had some floating point instructions in it, and there seemed to be a bug in it. It was assembly language. There seemed to be a bug in the program. I had to remove a couple of out instructions which don't really affect what's going on here. So that was in effectively flash or ROM here. Now I've changed that, and what we've got is the same code running on the Pico, so that is doing a transputer emulation. The program that's running on the Arduino is now different, and now it's basically just a pipe. So it takes transputer link traffic coming in from the transputer, or the Picoputer. It then just pipes that out of the USB using a fairly inefficient protocol, and anything coming down the USB it sends in the other direction to the Pico. So what I can do now is I can use the server program that's running on the other end of this USB cable to actually perform a transputer boot operation. So that involves sending a length byte and then your program, and that comes down the USB and then through the link adapter over the transputer link into the transputer that's being emulated here. Now the emulator now has been modified to accept the transputer boot sequence over the transputer link. The emulator, even though it's the same emulator, the bit that sits outside the actual emulation of the processor if you like, has now been changed, and that will now boot from link, which is one of the boot options of the original transputer. The other one's boot from ROM. Boot from ROM will probably never work on here. I don't have enough GPIOs and so on really to do that, and we've got 2 mega flash anyway, so we may as well just boot from the flash if we want to do that. So now it will boot from ROM. It's no longer using the hard-coded program, the hard-coded C array data in that chip. It's actually getting the data over the link. So it's a bit tricky to set up. I've got this programmed and that programmed. I need to reset this and then do some startup stuff over on the server. But if I do that, if I reset that, I'm now going into Eclipse and I'm going to run the emulator in the Pico. So that will start up. So I've got source level debug using Eclipse on the Pico here. That is now running, so all I need to do now, actually it's not running properly. There's a few problems with this because, oh there we go. So it booted up, started, and then the program was sent over the USB with full ACKs, so there's ACKs going on right the way from the Pico over to the laptop effectively. Pico sends a byte, it goes through the pipe and then gets ACKed coming the other way. So that actually comes over and sends the data down through this USB loaded into the emulator. The emulator, when it knows it's got all the data, because it's got a length byte, once all that data's arrived, it runs that code, which is what it's done. And over here you can see Hello World's appeared, and that has come from the program that was just sent over the USB. So it was a bit of a fiddle to get it all working, because you've got a bit of code here that talks to a bit of code here that talks to another bit of code on my laptop in two directions, using USB, a parallel interface, and then a transputer link. So 3 different protocols on 3 different bits of code in 2 directions. But it is now working. So Hello World has now been sent over to that Picoputer. Now what's nice about this is that from here on, from the IMSC 11 onwards, that is just standard transputer stuff. The Picoputer is emulating it at 3.3 volts, but what I could do is put a real transputer where the Picoputer is, and the rest of this wouldn't know anything about it. So this is now a USB attached booting device for a transputer system. So hopefully I'll be able to get some real transputer hardware hooked up to one of these things and see if I can get it running, which will be nice, because at the moment I think that's going to be the only way I'm going to be able to get Occam compiled to run on a transputer. There's quite a few Occam compilers that will run on x86s and so on, and I think there's one for ARM as well. There's some compilers out there, but what I really want is a way of compiling Occam onto a transputer, because I want to use a Picoputer emulator to actually run some stuff. But this is a big step forward, because it means I can now just boot up whatever code I want onto this Picoputer simply by booting another file. So I'm going to see if I can get some stuff running. Not sure what yet, but we'll see how we go. So I think it might be worth putting this onto a PCB, because it's a little bit hokey at the moment. I do need to change the inputs. I need to be able to run at either 3.3 for the emulated transputer or 5 volts for the real hardware. So it will need to just, I mean, it's easy, you just bypass these level shifters. I think I really probably want non-inverting level shifters as well, so I can run the same code on the Arduino. I don't really want to be running inverted data. I've done that because I've got transistors here just doing the level shifting and they just invert, but I think I need to stick some proper level shifters in there and actually run it that way, so that I've got the option of having real hardware going in at 5 volts or emulated hardware going in at 3.3. But yeah, quite pleased with that. It's actually working, so that's a big step forward. A lot of this wasn't really hardware, it was just code, just getting it all working. The protocol I've got here, this is running at what's it, 115/200 bits per second, which is pretty slow actually, but it's fast enough to get a program on there in a reasonable length of time. Maybe if I'm running larger programs I'll have to up the speed somehow. At the moment it's running in ASCII, it's not running in binary and things like that, so there's a lot of debug going on as well. So it could be sped up, but it's nowhere near the 10 megabits of the transputer link. Yeah. So next steps, not sure what the next steps are. Probably tidy it up a bit. Maybe get the hardware a little bit tidier so I can do the real hardware and the emulated. Maybe make a PCB up. Might stick with a prototype for a while until I've got some real hardware working, and see if I can get some other programs on there. I haven't got a lot of RAM on this Picoputer, that's the only problem. It's only 200k of RAM, which isn't really a lot. A lot of the original transputers had quite a lot more than that. So, well, not the transputer chips, but the some of the cards had quite a lot more, 2 mega RAM sort of thing. So yeah, might need to put some more RAM on there somehow, which is probably possible somehow, maybe, don't know, have to look at that.